In this video, we are starting section 1.2 on absolute values. Our goals are to simplify absolute value expressions, represent the absolute value of something minus something as a distance, and we'll solve equations and inequalities that involve absolute values. Okay, so in this video specifically, we're going to focus on doing some review of simplifying absolute values. Okay, so I want to get right into an example. So let's simplify the expressions without absolute values. Okay, so part A says, what's the absolute value of 5? So remember, the absolute value takes whatever is inside of it and turns it positive if it's not already positive. So 5 is already positive, so the absolute value keeps it as it is. It's just 5. What about B? What's the absolute value of negative 5? Well, it takes that number and it turns it positive, so it becomes positive 5. Okay, so not too bad so far. So now we're going to up the difficulty a bit. Part C and part D don't just have like a number inside, like 5 or negative 5. They have something with a variable inside. So it's unclear whether the thing inside is negative or if it's non-negative. So as a result, we're going to have to, the best we can sort of do with this is express it as what's called a piecewise function. We need two cases for this. Because sometimes, if the thing that's inside is already non-negative, well, it just stays as it is. It just stays as x. But if the thing that was inside was negative, we'd have to switch the sign, like we did with the negative 5 to make it a positive 5. So to switch the sign, the way I represent that is you write the x, but you put a negative in front of it, because that's going to switch the sign. Okay, and to complete the piecewise function, I need to write the word if on both of these and then describe, well, what does x have to be to make this be the value? So in this first situation, I needed the inside to be non-negative. So that's going to happen if the x is greater than or equal to 0. Okay, and in the bottom situation, for me to have to switch the sign, well, the inside of my absolute value, which is x, would have needed to be negative. In other words, it would have to be less than 0. Okay, so that's how I express the absolute value of x as a piecewise function with these two cases. Okay, so one quick clarification. So about the word positive, so I'm going to be using the words positive a lot in our class, as well as non-negative. And there's a distinction between the two. Positive just means things that are strictly bigger than 0. They cannot be equal to 0. 0 is not positive and it's not negative. But non-negative means it could be greater than or equal to 0. So that's why I was using the word non-negative to describe this situation, greater than or equal to 0. Okay, well, one thing we might just want to quickly check is, well, I got this piecewise function. If I graph that, does that match up with what I remember the absolute value graph is supposed to look like? Okay, so there's two pieces here. Let's draw each of them. So the top piece has x. Well, what does the graph of y equals x look like? Well, it's a line with slope 1 and the y-intercept is 0. So that would kind of look like, it would kind of look like this. It'd be like that. Slope of 1 through the y-intercept is 0. But I only want the part of it where x is greater than or equal to 0. So I don't want to draw the whole line. I don't want to draw the whole line. I only want to draw the part of it where x is greater than or equal to 0. This is where x is equal to 0. So greater than or equal to 0 is only this part on the right. Okay, and now let's draw the bottom piece. So the bottom piece is negative x. So now I want the graph of y equals negative x. Now my slope is negative 1. The y-intercept is still 0. Normally that would be this whole line, slope of negative 1 through the origin, but I only want the part of it where x is less than 0. I only want negative x values. So that's only the left half of it. It's only the left half of that line. Okay, so when I draw those two pieces, it makes this V shape, and that's what you might remember. Wait, doesn't the graph of y equals absolute value of x, it looks like that V shape. So in fact, the piecewise function graph matches what we know the graph of the absolute value of x to look like. So that's good. Okay, so let's do one more of these for practice. What if I have the absolute value of 6 minus x? Again, the inside is sometimes negative, sometimes non-negative. So I will need a piecewise function. I don't know because of the variable. So sometimes I'll be able to just drop the absolute value because the inside is non-negative. So I'll have to think about when does that happen, if, and I'll think about it. And sometimes I'll need to switch the sign of the whole thing. And to switch the sign, I got to put a parentheses around the whole thing and a negative in front of it, because this negatives it has to apply to all the terms. So that's why I need the parentheses around it. And again, I'll need an if. Okay, so when is it going to be the top case? When is it going to be the bottom case? Well, for the top case, I need the inside of my absolute value to be non-negative. So the inside is 6 minus x. I need that whole thing to be greater than or equal to 0. So the inside needs to be non-negative here. Okay, so if I were to rearrange this inequality and get the x by itself, well, we would get that x is less than or equal to 6. And if I just kind of think about that logically here, if I were to plug in a number that's less than or equal to 6 in for the x, like 4, well, 6 minus 4, that is non-negative. That's what I wanted, the inside to be non-negative. And that's good. Okay, so for the other situation, for the bottom piece, well, here I need my inside to be negative now. So if I want the inside to be negative, well, if that's the only other case, it should be kind of the opposite of this. So it should be that x is bigger than 6. And if I kind of test that out with a number like 7, well, 6 minus 7, no, that is going to be negative. It's going to be negative 1. So cool. So I got my piecewise function there. All right, cool. In the next video, we're going to talk about how to represent absolute values as distances.